Hi there. In this lesson, we're going to look at trigonometric questions involving bearings. Now, bearings are just really three-figure bearings, or numbers associated with compass points. So 0, 0, 0 is north, 0, 90 is east, 180 is south, 270 is west, and so on. Now, bearings are always measured from the north line round clockwise. Okay, so bearing of northeast would be round clockwise from the north line, and that would be 45. We use three figures, so it would be 0, 4, 5. So we're assuming you know that bearings are always measured from the north line round in a clockwise direction. A couple other things that become useful in bearings questions is this idea, first of all. If I know what this angle is here, it's useful to be able to work out this angle here. And I'll show you a really easy way to do that. If you remember F shapes and angles, there we are, like an F shape. You can see it's kind of pointing up the way, be like an F shape going up there like that. This angle here is exactly the same as this angle here. See this wee kind of pointy one there, an acute angle. They're exactly the same size. So we can get this one here by subtracting 40 from 180. Because a straight line makes 180. So 40 take away from 180 is 140. So we know this angle here is 140 degrees there. So it's really good to know that these two angles inside the north line add up to 180 degrees. It becomes useful. You'll see in the questions I do. Also, we expect you to know the full turn. So all the way around from start to finish in a circle and like that. I know that's not a very good circle, but that's 360 degrees. Okay, so if you've got angles round a point, they all would add up to 360. And the final thing, angles in a triangle add up to 180. It's another important point. If you add this angle, and this angle, comes to 180 degrees. Okay. Right, so this first question, I'm not going to fully do it, but I'll talk about it, and then I'm going to do three more kind of past paper type questions. Okay, so the first question here is a prove that USV, the angle USV is 65 degrees. So I guess you have to know what angle we're talking about, and you always look to the middle letter. So this angle is at S, so it goes from U to S to V, but it's really the one at S that I want. Okay. So we need to prove that this angle in here, if you like, is 65 degrees. And the way I'm going to do that is kind of a mixture of the things I did last time, the last screen. I'm going to try and work out this angle. And I'm going to try and work out this angle. And I then want to take it away from 360 degrees. Okay, so there's ways of kind of doing that, but that's the kind of basic idea. If I can get those two angles there, I can work out this by taking those two away from 360. Now, as before, when we looked at this, okay, we've got this angle here and this angle here inside the north line. So that kind of relates to that kind of thing. They add up to 180. So basically you just need to take that 25 away from 180, and that's going to be 155 degrees. Okay, so that's going to be 155. These usually pop up in calculator questions, so just take it away in your calculator. You should be able to do it in your head, but here. Right, the next thing I want to know is this one here, because if I can get this one and this one, take away from 360, get this one. Now it'd be quite handy to know this here. And if you look at this red part, what this red kind of circle line is basically saying that all the way around to there is 320 degrees. So all the way down to that point there is 320 degrees. So this means that the full turn's 360, to there's 320. So that would make that 40 degrees. Just because all the way around is 360 and the red bit comes to 320, so subtract that, you get 40. Now we're in the same position as this. If I know that these two add up to 180, that becomes 140. And then finally, if you add these two together, you're going to get 295, take away from 360, and you've worked that angle out. So no real trigonometry there, but just angles facts to help us get to the 65 degrees. Once you're into the trigonometry part, which is find the distance of SV, S to V, I'll get rid of all these bits just to kind of show us that there. Okay, so oops, I unveiled that, but right. So S to V is basically this letter here, this bit here. So S to V, we would call that small u, like that. And this one we would call small s, and this one we would call small v. They're opposite the capital letters. And I'm not going to fully do this, but basically I've got that 70 degrees in there. Now you might go, how did that suddenly appear, that 70 degrees? Well, we knew that the 320 was all the way round to there. And the picture also tells us that the 250 goes round to there. Right, so it's 250 to there and it's 320 to there. So you basically get the difference between, and it helps us to get that angle there. Now, good practice in trigonometry is to actually just work out the three angles in this triangle. So you could work out the one down here. If you add the 70 and the 65, comes 135. So that down there would be 45 as well. You could work that out. But anyway, right, so we're trying to work out S to V, so it's U. So you basically want to do the sine rule here. You've got a side opposite an angle. I should use a different colour thing there. You've got a side opposite an angle, and you've got a side opposite an angle. So that would be a sine rule question. But I'm not actually going to do that. It's not really the bearings, it's just the sine rule. Okay, let's try an exam paper question and actually do the working and figure it all out. Okay, so this is quite similar, this question. It came up in 2014, paper 2. The next video lesson I'll do 2 more, but I'll finish this one off for the first video lesson. I'll do 2 more in the second video lesson. Okay, so it says here, in a race, boats sail round 3 buoys, represented by A, B, and C in the diagram below. B is 8 kilometers, it says it there, it's a bearing of 60, C is 11, it gives all the information on there. And it says calculate the size of angle ABC. So again, we need to understand that that's the one at B. It goes from A to B to C, and it's always the one in the middle. Oh, that should straighten up. So it's this one here. So that one there, effectively, we're trying to work out. Right, so if we're trying to work that out, if I look at this triangle, I can see that I've got 3 sides on the triangle already, and to some extent we need to know our formulas. I'll bring that to the front just so there's not stuff all over it. Okay, so we need to know our formulas, and if you've got 3 sides, you can use the cosine rule to work out the angle, or one of the angles, any of the angles really. You can work out this one, or this one. So that points us in the direction of the cosine rule, just because we've got all 3 sides. You can see in the formula the small letters are the sides, and you can fill all of those in. Right, so I'll put that away. So we know we're going to use the cosine rule to work out this angle here. And I need to label the sides. Okay, so the sides are labelled basically with small b opposite capital B, small c opposite capital C, and small a opposite capital A. Right, so the first thing you want to do is write your cosine rule out, but you're using the capital B as a start, so cos capital B if you like. So we're going to write cos B, it's a squared plus c squared minus b squared all over 2ac. You'll notice the capital B at the start means the small b at the end, and the ac are in the other 2 parts. You basically just want to fill all the information in now. The a is 11, the c is 8, and the b is 13. So I'm just going to do that. Let's put it in like that. And just type it into your calculator. Now you can use the fractions button in your calculator, or you can use the divide button in your calculator and put brackets around. It's entirely up to you. But if you type that in, it should come to 0.0909, blah, blah, blah. Now, I tend to leave that in my calculator. And to finish off, you can work out the angle by just doing inverse cos. Okay, so shift cos, or that number there, and it should pop out to be 84.8 degrees. So we're basically saying that there is 84.8. I'll try and write it badly with my mouse, but 84.8 degrees. Now, the last part of the question, that's the first part of the question done. The last part says work out this shaded angle here. So again, we're going to use this idea of, if I know 2 of these angles, they all come to 360, and I can take 2 away and get the third one if you like. So again, back to this idea here. See this bit here? these two angles add up to 180. So if we look back to our diagram, I've got the 60 there, and this one comes to 180, so that's going to be 120. Okay, and to get the shaded one, basically if you take the 120, take the 84.8 and take away from 360. All right, so that's going to look like that. 360, take away 84.8, take away 120, and there's your final answer, 155.2. Okay, I'll do a few more in the next lesson.